Stars are enormous balls of gas, much bigger than our planet. They are primarily composed of hydrogen and helium, the two lightest elements in the universe. Despite their immense size, they appear as tiny points of light in our night sky. They appear as tiny twinkling dots in the night sky because they are very far away. The light from these stars travels vast distances, taking years, sometimes even centuries to reach us. This is why we see them as small, twinkling specks. The most important thing about stars is that they produce light and heat through a process called nuclear fusion. This process occurs when hydrogen atoms in the star's core fuse together to form helium, releasing a tremendous amount of energy. This happens in their cores where it's incredibly hot. The temperatures in a star's core can reach millions of degrees, creating the perfect conditions for nuclear fusion to occur. Nuclear fusion is like a powerful energy source that keeps stars shining brightly for billions of years. This energy radiates out from the core, traveling through the layers of the star and eventually reaching the surface, where it is emitted as light and heat. Our sun is a star too, providing light and warmth to Earth. It is the closest star to us and is essential for life on our planet. Without the sun's energy, Earth would be a cold, lifeless place. Stars are fascinating objects that play a crucial role in the universe. They are the building blocks of galaxies and are responsible for creating the elements that make up everything we see around us. From the smallest grain of sand to the largest planet, all matter is born from the hearts of stars. Sometimes, stars end their lives in a spectacular explosion called a supernova. Imagine the biggest fireworks show you've ever seen, but happening in space. These explosions are so bright that they can outshine entire galaxies for a short time. Supernovae are important because they release huge amounts of energy and matter into space. This material eventually helps to form new stars and planets. So, even though it's the end for one star, it can be a new beginning for others. Stars form from giant clouds of gas and dust called nebulae. Imagine a huge cosmic cloud, like smoke but much bigger, floating in space. Gravity slowly pulls the gas and dust together, making the cloud shrink. As the cloud gets smaller, it spins faster and heats up. Eventually, the core becomes so hot that nuclear fusion begins. This is when a star is officially born, shining brightly with the energy of fusion. Section 4. Stellar Showdown, Small Stars versus Massive Stars. Not all stars are the same. They come in various sizes and types, each with unique characteristics and life cycles. Some stars, like our Sun, are relatively small. These small stars, also known as dwarf stars, are quite common in the universe. These stars live for billions of years, slowly burning their fuel. Their long lifespans mean they change very gradually over time. When they eventually run out of fuel, they puff up into red giants, expanding to many times their original size, before shrinking down to become white dwarfs. These white dwarfs are incredibly dense and slowly cool over time. Massive stars, on the other hand, live much shorter lives. These giants burn through their fuel at an astonishing rate. They burn their fuel much faster, shining brightly but living only for a few million years, and end their lives in a much more dramatic way. When they exhaust their fuel, they explode in a spectacular supernova. These massive stars are the ones that create supernova. The explosion scatters elements across space, contributing to the formation of new stars and planets. Section 5. The weight of destiny, mass, and a star's explosive end. The most important factor determining how a star will end its life is its mass. This single attribute dictates the entire life cycle of a star, from its birth in a stellar nursery to its ultimate demise. Think of it like this: the heavier the star, the stronger its gravity, and the faster it burns its fuel. Massive stars live fast and die young, burning through their nuclear fuel at an astonishing rate. Small stars, like our Sun, don't have enough mass to create a supernova. Instead, they burn their fuel slowly and steadily, living for billions of years before gently shedding their outer layers to form beautiful planetary nebulae. But massive stars have so much mass that when they run out of fuel, their cores collapse. This collapse happens in a fraction of a second, causing the outer layers to fall inward at incredible speeds. This collapse causes a huge rebound explosion that we see as a supernova. The energy released in this explosion can outshine entire galaxies for a brief period, scattering elements across the cosmos. The remaining core can become a neutron star, or even a black hole if it's massive enough. These remnants are some of the most extreme objects in the universe, with neutron stars being incredibly dense and black holes having gravity so strong that not even light can escape. Please like, share, and subscribe for more videos. Thanks for watching, and see you on the next one. Peace!